Continuing with the problem, doing the algebra and cancelling out the L's, you will end up with this probability statement. Yeah, you have to find the probability that Z lies between negative 0.424 and 0.424. So we have got negative 0.424 and 0.424. So use the tables and arrive at your final answer, 0.328. Yep, you can check the numbers. Okay, let's say we have X and Y. They are independent random variables. X is normal with mean 20 and variance 9. Y is normal with mean 30 and variance 3.5 squared. We want to have a quick discussion on some of the possible questions that can arise in a statistics exam, right? So we're not worried about the exact question, but the ideas behind it. Yeah. So anyway, I give you two normal random variables with their means and variances. We want to consider the distribution of W. Note, they are independent random variables, yeah, X and Y. So let's say we have W and we define it to be X plus Y. Note, W is good, the normal. I've said it before. And what's the mean? Just add it up, yeah. 20 plus 30 will be 50. The variance of W will be variance of X plus variance of Y. We have this 9 plus 3.5 squared. You'll get 21.25. Okay, now that you know that, we want to work some probabilities. Huh? If they ask you to find the probability that X plus Y is less than some number. Yeah, let me move the screen. Okay. So we want to find the probability that the sum of the random variables X and Y is less than 60. So we have called W, we have called X plus Y as W. We have referred to X plus Y as W. So basically we are trying to find the probability that W is less than 60. You know the mean of W, you know the variance of W, and you know it's normal. So what do? Good, change W to Z. So you take 60 on the right hand side minus the mean of W over the standard deviation, which is the square root of 21.25. So that's what happens here. Probability of Z less than this, and use your calculator, you'll get probability Z less than 2.169. Look up your tables, read off the value, you'll get 0.985. Again, another random variable X, normal, mean 164 and variance 5 squared. And Y is normal with mean 173 and variance 6 squared. You're asked to find the probability that X minus Y is bigger than 0. So if you let W equals X minus Y, then the expected value of W will be the expected value of X minus the expected value of Y minus 9. Okay, that's what you see here. Then the variance of W will be the variance of X plus the variance of Y. So variance of X, what is it? 25. Variance of Y is 36. You'll get 61. Careful, right? This is plus, yeah? So now you're ready to solve the problem, okay? We're looking for probability W bigger than 0. So probability W bigger than 0. Okay. So we have, hang on. W bigger than 0. So let me write W bigger than 0. So change your W to Z. So you can write Z bigger than, what's the mean of W? Minus 9. And what is the standard deviation of W? The square root of 61. So that's what you see here. Okay. 0 minus 9 is plus 9. And then when you work this out, you are going to find the probability that Z is bigger than 1.152. Use your tables. Yeah. Use your tables. And you'll get this number here is 1.152. You'll get 0.125. Okay. Good. Now let's look at, hang on, let me look at, I want to talk about another approximation, but never mind. Before that, right, let's just talk about the Poisson distribution first. Okay. I want to talk about another approximation involving the Poisson distribution, but never mind. Let me just come back and talk about a few ideas involving the Poisson random variable first. So note, if X is Poisson with mean rate 2 and Y is Poisson with mean rate 3.5, so you can say lambda X is 2 if you like, lambda Y is 3.5, okay? The important thing, X and Y are independent. You asked to find the probability that X plus Y equals to 6. So we want to use the same idea as before. W equals to X plus Y, right? So what's the expected value of W? In this case, it will be lambda W will be 2 plus what? 3.5. It will be 5.5. Okay, there you go. So W is Poisson. W is Poisson with a lambda will be 5.5. So you want to find the probability that W equals to 6. Can't be easier than that, right? We'll use the formula e to the power minus lambda, lambda to the power of x over x factorial. Okay. So now x is 6. Just plug in, right? Use the right lambda value, x value, calculator, and we're home. So what's the point, right? If x is Poisson with mean rate lambda 1, y is Poisson with mean rate lambda 2. Okay. So if this, right, and this, if x and y are independent random variables, then the point is w, which is x plus y, is also Poisson with mean rate lambda 1 plus lambda 2. I just stopped at, you can also have, you know, you can have, let's say we have some number, right? V, right? V equals to x plus y plus t plus u plus, what I'm trying to tell you here is, here we only talked about 2 of these, right? We can extend it to 3 or more, right? The idea will remain the same. We just add up the lambda 1, lambda 2, lambda 3, lambda 4. So this thing now becomes a new Poisson random variable with the sum of their lambdas.